welcome Seth Juarez.
Good morning. How is everybody doing today? I'm excited about Connect because Connect is a different kind of event. We always do things a little bit differently, and this keynote is no different. Microsoft has a ton of tools that we need to talk about and we need to show, but for this keynote, we're going to focus on a concept, and we're going to show you how our tools help you with that particular context. Today, we're going to be talking about building the intelligent apps of the future, what it means, how we do it, and how we can actually get started today. And I think I'll start with the story of how I actually got here. It's kind of similar to the story that you usually have. And so as we talk about applications of the future, think about these elements in my story and how they relate to your life. And as we're going through, you're hopefully going to be inspired of applications that you have in production today where you can say, hey, you know, I can sprinkle a little bit of that in here, or I can put a little bit of that in there. And as you do, you're going to see that your applications are going to be applications of the future. All right. So when I came here last Friday. The first thing I did, and I don't know if you're like this at all, but I don't like waking up in the morning. I think I'm getting old. I have a special alarm clock that measures my movement. And what it does is it sets a half hour aside to measure when I'm moving the most to wake me up gently. It's super nice. So that's the first thing that wakes me up. Now, I'm going to tell on myself a little bit. I don't know if you're like this, but the first thing I do when I wake up is I look at social media. I don't know if you're like this, so no judging, no judging. And as I look at social media, it tells me, hey, you should be friends with this person. I'm like, yeah, I should be. I haven't seen them in 10 years. That's amazing. I upload a picture, and it knows who's in it. I can also do things like interact with a publisher, put in an ID order number that I put in, and it gives me back when it's going to show up at my house. It's pretty amazing. The next thing I do is I need to get ready to get to the airport, and as you know, I'm flying from Redmond all the way over here. It's about a 5-ish hour flight. It's long, but did you know that only about 7 minutes of that entire flight is actually manned by a human? 7 minutes. Do you remember the first time you got the internet on the airplane and everyone did the tweet, hey, I'm tweeting from the airplane? I didn't do that. I didn't want to be corny. But maybe you did. That's okay. No judgment. But when we got the internet, it allowed me to be productive on the airplane. So the first thing that I did is I started to look at my email. And there's an interesting program inside the email that removes all of those emails that we just don't want to look at. And it's pretty good. It's very good. The other thing, and this is important, right, because my wife's birthday is coming up. I wanted to check to see if I could buy her something nice. And it turns out that when I looked for something, it always suggested something better. It was as if my mother-in-law was with me behind my shoulder telling me, no, she won't like that. It's really nice. And last but not least, there's some gaming that I love to do on my phone, and it turns out that it's really hard, and I can almost never win. It's really sad. As soon as I land, magic. I land, and I can go to my phone and say, hey, I want to go to this place, and the app tells me who's going to show up, when, how long it's going to take, and it also literally tells me how much it's going to cost. And I literally walked out of one of these last night, and my wife was like, hey, aren't you going to pay him? It's done. Right? These applications we've all experienced. They're a little bit different. How do we make them? These applications of the future are everywhere. And we're going to talk about 3 principles today that are going to help us understand how to build these. And you've already done a little bit of this, but if you add just a little bit more, it's going to change the way we're doing it. The first thing is that all applications of the future are AI infused. They are. They're very powerful that way. The second is that they create new experiences. I had an app interact with me while I was sleeping. And the third, and the most important, is that they are data-driven. Now, today's keynote, like I said, is going to be a little bit different. We're going to be talking about these 3 concepts of building applications of the future. I've invited some friends to help me do this. And we also have some special announcements at the end that you're going to want to stick around for. Because when we're doing these things, I want to tell you that we're going to be doing real demos with real code, with things that you can really do today. In fact, if you're watching online, you can follow along and do almost everything that we're going to do today. All the code is going to be available for you to look at and to understand and to actually use. All right, so let's start with the first principle. Remember, it's infusing AI. Now, AI is an interesting term, right? Because it feels like it's a little bit overloaded. You know, AI this, AI that. You know, we do AI when we want to sell something. We talk about machine learning when we want to hire somebody. That's the difference. No, that's not true. AI is a concept that allows machines to be intelligent. Machine learning just happens to be one of the best ways to do it. So we're going to talk about that. Think of machine learning as a set of intelligent libraries. And I'll tell you, I used to work for a component vendor, and follow with me here, because you might not follow it first, but you will. How many of you have used a PDF before? Almost everybody. Does anyone know how a PDF is written in code? I have not a clue. Like I said, I worked for a component vendor, and I would pass it the path of a docx file, and it would happily spit out a PDF. And if something was wrong, I would go ask somebody, and they would fix it. I'm like, this is great, right? It turns out that if you think of AI as something that you call first, instead of something that you build, which we'll talk about at the end, it becomes a lot easier to think about. We are okay with abstractions. We are okay calling this scary PDF library that does who knows what, but it does the right thing. And so today we're going to start out by talking about something called cognitive services, which is effectively something you call. And instead of us trying to be super intelligent about the algorithms we write, instead we can use intelligent libraries to infuse AI into our applications. And to help me show that off a little bit, I've invited Anna Roth to show me that. How you doing, Anna? Fantastic. So let's start off with the easy stuff. Why don't you describe cognitive services to us in the audience?
Sure. So cognitive services are a set of cloud services in Azure in the areas of machine intelligence. So they make it really easy to do things like computer vision or natural language processing or speech processing. You know, it's as easy as doing a REST API call.
Fantastic. So can you show us an example of this? Because I'm dying to see how this works.
Sure. Let's take a look at a couple examples. So here I am on the cognitive services site. You guys can follow along at home if you want. And let's actually start with speech.
Okay. So again, this website everyone can use and go to it right away.
Yes, yes.
Okay.
So I can do something like, I'm having a wonderful time in New York City. And you can see up there, it's transcribed what I've said. So you've got kind of speech to text.
That's pretty amazing. And now, like, as a developer, am I just calling them? I'm trying to understand it. I mean, is this like a magic thing that we're showing, you know? Like, I want to see behind the curtain a little bit.
Sure. So this is, you know, here I've used like the web demo, but actually you're just doing a REST API call. So you're sending up an audio clip and you're getting back a structured output, which is like the text that was spoken in the audio file.
Fantastic. Do you have any other examples of cool stuff to show us?
Yeah, let's take a look at a couple. So our text analytics API lets you get a couple of things. So you can do, so you know, here's kind of a sample sentence. I had a wonderful experience. The rooms were wonderful and the staff was helpful. You can imagine that this is somebody's review that they've left on your website. And so we get this structured output when we send this to the text analytics API. So we're told what the language was. So here with high confidence, it's English. We identify key phrases. So wonderful experience, staff, and rooms. And then we also get a sentiment score, which in this case is very good. And so this is the JSON you would get out from if you had done this as an API call.
Fantastic. So as a developer, just call, send some text. It tells me what language is in, how it feels or they feel about me. This is pretty amazing. You got anything else?
Yeah, let's take another look. Here we have our computer vision API. So in this case, what you're sending up is an image. And so I can send this image to the computer vision API, and I get some information back. So I get back some tags here, like that this is a train, station, indoors, subway with a certain degree of confidence. And then the neat thing here, too, is that I get a natural language caption. So I get people waiting at a train station. Now, that's based entirely on the contents of the image. So we've analyzed the contents of the image and given a natural language caption. It's a nice example of having folks on our NLP team and our computer vision team actually work together to build out this technology. And it's used today in Office, in Word, and in PowerPoint to generate captions for accessibility purposes. So people who are sight impaired can get automatic captioning to see what's in the images.
Awesome. I love how this is something that you just call, an intelligent library you can just call. But what if I want to make it a little bit more custom, more my own? Can we do that?
Yeah, absolutely. So customization has become a big focus for the cognitive services. Historically, it's been you have a piece of content, you send it out, you get a structured output. But now, in some cases, you do want to customize. So, for example, we saw speech to text earlier, but say you work in an industry that has a particular jargon, so like particular phrases and words that are used in your industry, or say that you have a particular audio profile. So, you want your speech to text system to be used in a factory or in a drive-through or somewhere where you have kind of consistent background noise or consistent microphones, et cetera. You can actually customize your speech to text system to perform better in those particular conditions. So you can use our custom speech service to get yourself a customized speech endpoint for your particular scenario.
Fantastic. Do we have a demo of something we can customize today?
Yeah, let's take a look at an example in the vision category.
Okay.
So we have this service called Custom Vision Service. Now, this is a tool for building image classifiers. So what you do is you give it a couple of examples, and you get an image classifier. But the neat thing is that you're doing this in the same interface as all the cognitive services. So these are just REST API calls that you're using to build an image classifier.
Mm-hmm. That's awesome. Well, let's see it. Let's see it in action.
Yeah, absolutely. So I'm going to show it to you here on our website, like on the web portal. But the important thing to note is that everything that I'm doing here on the website, you can actually do using API calls. So the website is built entirely on the public APIs.
All right, so let's see it.
Yeah. So here I've built like a little classifier that can recognize a couple of different kinds of fruit. So, say oranges or strawberries, et cetera. And so I provided some example calls earlier. It takes about 10 minutes to build an image classifier using this service. And we've designed it to be really, really easy to get started and then to iteratively improve your classifier. Our sense is when you're working with computer vision applications, you often will find that, your first run may need a little more work. You may need a couple more examples. Here, I want to actually add a new class. So let's say I want to add images of apples to my classifier. I can just upload a few. So let's make a new class called Apple.
So it looks like you're only uploading 136 files. My training in machine learning tells me I probably should have a little bit more for it to be smart. How is it that it's doing this?
Sure. So we're using techniques, we're using transfer learning-based techniques to make these image classifiers. So the nice thing is that you need only a handful of images, so on the order of, say, 50-ish per class to get started, to build like a good base classifier. And then training is also really fast. So we can start training now, and we'll expect to be done within, a couple minutes, a minute or two.
Fantastic. So all I need to do in Custom Vision Service is upload my own pictures, tell it what class it is, and it's going to be able to distinguish on its own.
Yes. And so in the back end, we're doing a lot of things to help you automatically build a high-quality classifier. So things like data augmentation or building a negative set, all the kind of like tips and tricks that our computer vision experts normally use in building, the cognitive services, we've actually built in as heuristics, as kind of automatic tools in the classifier. So I'm actually done training now.
Fantastic.
And so I can show you. We have some information about the quality of our classifier here, but what I actually get here is that my model has been hosted for me at an API endpoint. So I can just call it the same way I would call any other cognitive services to get an image classified.
That's awesome. So so I understand it has to be an API call, but what if I'm in my car and I go through a tunnel and I really need to classify the fruit in my car?
Yeah,
What do I
absolutely.
do then?
So do a quick test.
This has happened to all of you. I know this. This is the case.
So let's grab, just to get a sense. So this is what we would have gotten if we'd used the cloud service. We would have sent this up, get a classification back. OK, it's an apple. But yeah, there are lots of cases where, let's say, you have like latency issues or network connectivity problems. So you want to do your processing offline. And so that's why we've introduced model export. So for this service. So what you can do is take your model that you've trained and actually download it locally to run it on a device. So right now we're supporting export to the Core ML format for iOS 11. And a couple of weeks we'll add Android in the mix. So all I've got to do is I can select Core ML, hit export, and in a couple of seconds my model will be ready to download. And I just get a model file that I can put right into my application for near real-time, completely on-client prediction.
That's pretty amazing. And you can do this all on the website right now. If you were following along, you should have been able to do this too.
Yes.
Awesome. Well, thanks so much, Anna. That was amazing.
Awesome. Thank you.
All right. So notice that we downloaded this model It was very easy to do, and we were able to do it pretty easily. What I've done is I've invited my friend Miguel de Icaza to actually take this model and put it into a Xamarin application. How are you doing, Miguel?
I'm doing great. Thank you, Seth.
Fantastic.
All right. So what Anna was saying is essentially that now we are allowed to take these models that we've trained on the cloud, and we're gonna create a model that can be run locally on device, like you were saying. Apple recently released a device-optimized machine learning framework called CoreML. It's been optimized to run on your iPhone devices, and Android and Google has done something similar for Android. So what we have here is a C# project using the native APIs for iOS to record video. We're going to record live video, and we're going to send all these data to the local model using CoreML.
So I have to admit, I've never written a Xamarin application, and it's kind of embarrassing that I'm admitting it in front of all these people. So maybe be gentle with me.
I will be gentle with you. Now, it's worth pointing out that this is not limited to C# and Xamarin. This works with Swift, right? So what you have here is the fruit.ml model that you could consume either from Swift or Xamarin. And what I have here is a C# app that uses the native APIs. The view controller is the base foundation on which you build a screen on iOS. And what we have here is a couple of things. First, we set up the recording, the camera recording equipment here. It happens right here in Setup Camera. We called AV Foundation, which is Apple's native library for recording video. We configure the video, the resolution that we want to capture, and also we specify the handler for every frame. So every time there's a frame coming out of the video, we're going to send it to this method. This method will do a little bit of throttling, so we don't continuously run the model and don't burn a lot of battery. And what we're going to do is we're going to classify that, right? So we're going to send the frame over to CoreML to tell us what it is, right? So let me go back up in this buffer, and I'm going to show you, where's the mouse? Where's the mouse? Oh, I can't see the mouse. I'm just going to scroll because I can't see my pointer. So I'm going to ask you to look through the code. So there's a couple of things here. On line 59, right here, that line, what we're doing is we're fetching the model. We're going to load the model here, and we're going to pass it to CoreML. So this is the native iOS API. We're saying, please load my model, and then create a vision model out of this thing. Right? And then later on, there's a callback here, handle classification. So every time we get a frame, we're going to invoke this little method that is going to fetch the results. These are the observations that you have here. And we're just going to display that on the screen.
Fantastic.
So let's take this app for a spin. We have Android devices and iOS devices
here.
Let's do it.
I believe you have your pen there ready to go.
I have a pen.
So let me get, let's see what we got down here. I got an Apple right here.
We got a pen. We got an Apple.
OK.
And we should switch the phone so the folks here in the audience can see it. So I'm going to launch my app, and I'm going to point at my Apple. That recognized it. Now, what is interesting here is that this is not going to the web and hitting the web endpoint. This is running locally. So to do that, now that I have a different iPhone, I forget how to do this. So I'm going to, we're already in airplane mode.
It's already airplane mode.
So this
is happening on the device.
Yes. Yes. Now let's say something else. So again, I got my pen.
Let's see. What else do we got?
We got a pineapple.
I think we may have something like that.
We have a pineapple.
Right here. Let's see. Oh, my goodness.
We got a pineapple.
So if you're driving in a tunnel, you can totally do all your fruit classifications in the tunnel, no problem.
Yeah, pens, apples, pineapples.
Fantastic. Now the code, thank you. I mean, that was pretty amazing.
Yeah, thank you.
So just to finish up, that code that you had, where can we get that?
Well, when you go to the website, you'll be able to get the sample to get you started with live thing. And just as you guys know, we always have a backup for everything here. So we also have so we brought a backup pineapple in case the first pineapple didn't work.
I think we'll just leave it here. It makes everything a little bit better.
All right.
Thank you so much.
Thank you very much, Seth.
Thank you so much. All right. So as you saw, the first principle of intelligent applications of the future are that they are AI infused. And just like that PDF library, you're all happy to abstract away. You can abstract away intelligence right now in your applications. These can be in there right now. Not only can you use them as API calls if they're on your website. For example, if any of you ever have to do a help scenario, wouldn't it be nice, to know what's going on there easily? If any of you need to recognize an image, like I did when I woke up and I submitted a picture to my social media app, you can do that right away. And you can do it as an API call, or you can load it in locally as a core ML model, and also TensorFlow if you want to do it inside of your Android application. Okay, so the first principle, again, is applications of the future are AI infused. Principle number 2 is that they provide new app experiences. Technology is moving to a place where the barrier between computer and human is becoming more and more blurred. No longer can we say you are not using it right, because our customers demand more. They demand experiences that make them feel immersed, that make them feel like they are part of the actual program and that we've thought of them as a person. In order to help us show a little bit more about how these new experiences can change the way your users interact with your programs, I've invited Heather Shapiro to show us an awesome demo on bots. Come on up, Heather.
Thanks, Seth.
How you doing, my friend?
I'm good.
Fantastic. So why don't you tell us about bots?
Yeah, I'm really excited to show you how easy it is to get started with bots and how easy and simple it is to integrate AI and our cognitive services tools onto them.
Fantastic. All right, let's get started. Where are we at right now?
So here we are in the bot service in our Azure portal, and we can quickly enter in an app name. So connect bot demo New York City, and we can put in our credentials, resource groups, and create that.
So what is it that this is making?
Yeah, so what is a bot? When we think of a bot, we can think of it as a new type of application where we are communicating with our users in a different way. So you can communicate with your user through text, through cards, through even speech. And it could be as simple as back-to-back dialogues, or you can also infuse AI through business intelligence and other artifacts that you already have.
So effectively, it's text coming in, and we're going to respond somehow.
Yes, exactly.
Fantastic.
Yep, and the bot service allows us to accelerate this process of creating a bot. So in the Azure portal, we can have 2 templates that we can choose from, so C# or Node.js. And since Miguel was just looking at C#, we're going to take a look at Node.js. And we have different forms. We can do basic, language understanding, Q&A, different types that are already there straight out of the box that we can get started with. And we're going to take a look at language understanding today.
Fantastic.
And I've already created this, and we'll go into what language understanding is, but let's just pull it up in Visual Studio Code.
And this is just something we downloaded from that portal.
Yep, exactly. Okay. So straight out of the box, right out of the Azure portal, I would have gone through and made an app ID, and it takes less than 5 minutes, but for the sake of time, I already created that zip. And right here, we have a fully functional bot that has everything you need from a Node file. And it has all the requirements. I would just put in my Lewis API key, my app ID, and all that.
Fantastic.
Although if a user says anything, all they'll see is, sorry, I didn't understand that right now.
So this is the real getting started one. We're not, like, nothing up our sleeves. I'm not wearing sleeves, by the way.
Extreme getting started. It's not that smart yet.
OK.
But we can make it smarter.
All right, how do we do that?
So we can add language understanding to it by going through Lewis. So Lewis is one of our cognitive services, stands for Language Understanding Intelligence Service. And it's an API that you can call straight from the bot. And it allows us to add intents. And when we think of intents, it's what the user actually wants us to accomplish. So when you're creating an app, there might be things like calendars or events or different pre-built domains or domains that are pretty common. And we have these domains that are already in Lewis that you can add in.
So these things are just libraries of things people might say that are related to movie tickets or fitness or events.
Yep, exactly.
Okay.
So they're just different phrases that people might say that you can automatically add into your app to make it smarter.
Fantastic.
So we're going to get started with the weather app today.
Of course, because that's always the topic of conversation.
Always important, especially in New York.
That's right.
So we can add that pre-built domain in. And now if we go and look at the intents, we'll take a second. So what will pop up, we have get weather condition, and then we'll also have get weather forecast.
Okay.
And when we think about get weather condition, we can think, OK, what's the current weather? So we want to think about weather trends. So is it raining in Seattle, or how often does it rain in Seattle? And when we think about weather forecast,
there you go.
Yep. So it took a few seconds, but now we can see a bunch of different utterances of what people might say. So there are only 14 utterances here for each one, but it makes the bot smart enough to be able to understand different intents. So for condition, what's the weather like? And then for forecast, we're trying to predict for the future.
All right, so these are just examples of things that people might say to your bot about the actual weather.
Yep, exactly.
Okay,
so
fantastic.
people can say different things, and it will look for similar phrasings and create that language model for you.
Fantastic.
And so you can train the application and then publish it. And that will take a second. Then if we go back to the bot, so I have some code already that should be in my handy dandy copy and paste.
Very good.
And so what this is doing, it allows us to automatically access the Lewis API. And so we created those get forecast or get condition intents. And we can now say, OK, if the user says something that matches that get forecast intent, let's say you asked for the weather forecast. If they said get condition and match that, we'll say you asked for the weather condition.
Awesome.
So we can go ahead and run this. Make sure that's saved.
And this is the real Node application. We're not like faking anything right now.
This is real, all in real time. And
Fantastic.
So now it's opened up in the bot framework channel emulator.
So what is this thing? Is this like a special program? I mean, tell me more about what this is doing.
So this emulator allows us to run this bot locally. You can also test it against bots that are deployed already to Azure or whatever hosting service. And then you can also deploy this bot to different channels. So one of the nice things about the bot framework is you write the code once, and then you can deploy it to different channels, say Facebook Messenger, or Slack, or Teams, Skype. So there's all different channels that are supported by the bot framework.
Fantastic. All right.
So now if we test what we just deployed, what's the weather this weekend? It'll say, you asked for weather forecast. If I say, what's the current weather? It'll say, you asked for weather condition.
And that's pretty amazing, something we just did live on stage right now. I think that's pretty amazing, don't you? So for those that are watching, do you have an application you can show us that can inspire maybe what people can do in the future?
Yes, so recently we actually worked with the Institute of Precision Medicine at Weill Cornell Medical College here in New York City. And they're working on a precision medicine knowledge base that will help clinical cancer clinicians, researchers, doctors, organize their precision medicine knowledge base. So this knowledge base has hundreds of genes, variants, and cancer interpretations. And as you can imagine, it's usually very time sensitive, and there's a lot of interpretations to go through. So we recently worked with them to create a bot using the bot framework and then added Lewis on top of it. And it allows the doctors to get back to their patients. It gives them more time to focus and enhance their patients' experiences.
All right, let's see it in action.
Perfect. So I can get started and say, find breast cancer tumors. So this is in our Skype interactive bot.
Sure.
So we can find breast cancer tumors. And we get all the interpretations for breast cancer tumors.
That's pretty amazing. Now, you worked on this application yourself with a couple of other people. How long did it take to make this?
So it took about a week, and we deployed it in April. And since then, it's quadrupled in the amount of data that they've had and genes that they've had. And they're currently using it to test for certain New York State clinical trials for leukemia testing and DNA sequencing.
So what's in the future for this application?
Yep, so for the bot itself, they're looking to put it fully integrate it with Cortana skills and Cortana itself, and then also to fully integrate with the Invoke speakers that are coming, that have just been released.
This is amazing. Thanks so much, Heather Shapiro.
Thank you.
Notice, the cool thing about this, again, is that adding new experiences was really easy when we coupled it with the cognitive services in Lewis. Bots is a new way to interact with computers. It feels more human-like. And as you're watching, you're probably thinking, I could probably put a little text box at the top of my app today. And if the user doesn't know what they want to do, they can just type it in. And with the power of Lewis and the power of bots, you can create experiences that feel more native to your users right now. So that's the first thing. The first thing, again, was the principles of applications of the future. Number one, infuse AI. They are AI infused. Number two, they create new experiences. And finally, and most importantly, they are data-driven. They're all data-driven. Let me tell you a little bit about my particular experience as a developer. I started out as an ASP.NET MVC 1.0 developer building globally distributed applications where the hardest thing was literally managing time zones. You all know what I'm talking about, right? That was the hardest thing. I decided to go back to school and learn a little bit about machine learning. And to be honest, it felt like I was kind of outside of the Microsoft world. I did everything in Python, I did R, and I did MATLAB, is how I did this. So what I want to do is I want to tell you a little bit about how to think about now machine learning, okay? Now is the time where I'm just going to sort of peel away a little bit of the hype. I'm going to show you under the covers what is actually happening. And it's my opinion that everyone can understand what is going on. Even if you might not know the math or you might not know how these things are being generated, every one of you can understand what is going on so that now it can become, instead of a marketing problem, an engineering problem. And that's what I'm going to show you today. So the way we're going to do this is we're going to look at an example. Pretend your boss, Sally, comes to you, Jim, and says, Jim, you're our best engineer, and we want you to build an application that recognizes handwritten digits like this. For those of you that are data scientists, I know this is the canonical hello world problem, but go with me here. So imagine your boss comes and says, okay, I want you to build an application that will recognize handwritten digits, and you get it in a square image file, each digit. As a programmer, before I went and started learning about machine learning, what I would do is I would look at these things and I would be very clever, right? The first thing I would do is I would look at the number 1, I'd be like, I can do that one easy. If a lot of pixels in the middle and not a lot of pixels on the side, 1. So smart. I learned how to classify 1, just easy. I can do that. Now, what I can do is if there's a lot of pixels on the side and a lot of pixels on the top, 7. Right? So notice now we have if, pixels in the middle, 1, else if, you see what I'm saying? We've all written code like this, where there's a lot of if statements. And to make it work even better, you had to add an if statement again in your next release. Or you had to change the number from a 0.5 to a 0.7, and it just magically worked, and you felt like something's not quite right. It turns out that machine learning is a great tool to use on these exact problems. The problems that feel a little fuzzy, that feel a little more human. Because instead, with machine learning, instead of focusing on the actual steps that we're going to take, instead with machine learning, we focus on the examples that we give the machine. We give the machine examples. Instead of thinking about a series of steps that you're going to take to solve a problem, we're going to make these things called models, right? So instead of code, we have models. Instead of steps, we have examples. That's a little bit different. It feels like we're relinquishing a little bit of our smartness, right? Because I thought I was clever because the pixels in the middle thing, but obviously it's not going to work all the time. So let me talk a little bit about the machine learning process and how we actually go through it. The first thing you always have to start out with is you need to have a sharp question. What is the question here in this problem? Can I, from a series of bits in a picture, give you a number? That's the problem. So once we know what the problem is, we need to come up with, well, where's the data coming from? I need to have a set of pictures that have the actual number in them. And we have that. That's the MNIST data set, which all data scientists use in their first class to predict stuff. The second thing we need to do is that these algorithms don't understand pictures. They understand things that look like this, like arrays of bits. So we need to take this data and we need to format it in a way that the computer understands. We also need to take out the ones that are just not good examples. Like, let's just say, for some reason, one of the pictures snuck in and it was all black pixels. That's not going to help you classify. Once you've done that, the next thing you're going to do is you're going to generate this thing called a model. You saw that a little bit when we were doing the stuff in cognitive services. She downloaded a model. That's the output. When we're thinking of engineering problems, we're thinking, okay, what's the artifact? What's the output? For us, there's these things called models. And finally, you use this model to actually make the prediction. You saw a hint of this when we did the cognitive services fruit demo, and I left these up here for you to remember, right? For Microsoft, we are very proud of the tools that we built. And in order to help in these things, we've already built a number of tools that help out with that. For example, Visual Studio Code tools for AI. We also have Azure Machine Learning Studio, which lets you drag and drop things to create models. We also have Azure Machine Learning Workbench, which is fabulous for cleaning up your data and getting it into a way that you want to understand. But just like a hammer doesn't care what nail it works with, there's also a ton of frameworks that you can use to make these things in these tools. For example, we have Cognitive Toolkit, or CNTK as it's been known as. Also, we have TensorFlow, Caffe, anything, right? But you shouldn't think of these frameworks as being tied to our tool. You can use whatever you want. You know, any program, any code, whatever you need. But it feels like something is missing. Today, I am proud to announce Visual Studio Tools for AI. This marries all of the goodness that you have in Visual Studio with all of the goodness that you would do as a data scientist. And not only that, it's actually coupled to the cloud in a very powerful way. And I'm so excited about it that I thought I would do the demo myself. All right. So here we are in Visual Studio. Before we even get started, because there's some code already there, I want to show you that if you were to go to the new AI tools and go to the Azure ML Gallery, you can literally do this now. This is available at aka.ms, VS Tools for AI. You can download it and play with this right now. Notice that we have a bunch of examples already in there. The example that I'm doing is MNIST, but I'm using CNTK. Notice that it doesn't matter if you use TensorFlow. These are the simple getting started examples. As we go down, notice that there's even more things that you can do that are more aligned with some of the stuff that you will do in your business. But right out of the box, notice how productive Visual Studio Tools for AI are making you. You can get started right away. Okay, so that's the first thing. I'm going to go ahead and close this. Now, the other thing that's really cool is notice that we have this beautiful Python environment in order to run the model or to create it. So remember, what we do is we get a lot of data and we need to train this model, and I'm going to do it right here. And notice that we have everything here in Visual Studio. I'm going to go ahead and set a breakpoint. Oh, I already did. And what I'm going to do is I'm going to run this like this. And boy, I sure wish I had this in school because I literally had to do a lot of print statements. Notice that the breakpoint is set. As a developer, you're accustomed to some of the wonderful things, like, for example, seeing what's in your locals. I'm going to go at an F10 so you can see things filling out. Everything you've come to know and love from Visual Studio, direct in here. Now, remember, I wanted to show you a little bit of the process, so I'm going to actually let this run and go back one step and show you the data that we're giving this algorithm and how it's actually running. So I'm going to minimize this here. And I am going to go to the data. And notice that the pictures that we're using are literally pictures like this. But remember, the computer doesn't understand that. So we actually have to convert it to something that looks a little bit like this. And this is going to look funny at the beginning, but once I explain it, it's going to make perfect sense. Notice that at the left, we have this thing called a label, which is what we're trying to predict. Notice it's not a number in this case. We're just putting in the slots from 0 to 9, which number that is. If you count closely enough, the first one is an example of a 7. And then this is a 28 by 28 pixel image, and so it's literally the bits from 0 to 255 of the color. Let me show you what that looks like. So that's what the computer sees. That's cool, right? I thought it was pretty cool. It's just made up. Notice that we have a bunch of numbers that say how dark or light it is. And around it, we have the color. I think it's pretty amazing. And hopefully I've stalled long enough for this to be done. Right? Because I actually wanted to run this model. Now, this takes a long time on my local machine. But one of the things that we're thinking of as developers is how do we actually know if this thing is working? Right? How do we know it's working? Usually we have these beautiful things called unit tests. Let me show you the kind of unit tests that a data scientist would use. So I'm going to go ahead and close this out, go back to Visual Studio, and I'm going to right-click on this and run something called TensorBoard on the actual output of what we just ran. So as this is loading up, let me tell you, what's happening is the computer is getting all these examples, it's crunching through them, and it has this function that measures the goodness of the model called an error function. And what we want to see is we want to see that error going down. And hopefully that's what you see, right? The error is going down. And that's how you know. It's kind of like our little unit test for data science models. Okay. But remember how I had to stall a little bit to make this thing run fast. You know, that's kind of embarrassing. One of the cool things about Visual Studio Tools for AI is we can run these models in remote compute context. And let me show you the one I have set up here. Because remember, back in the day, when I had to run these things, I had to rent time in the computer lab, and Jim was not nice to me because I was not like high on the totem pole and say, yeah, sure, come in between 2 and 3 in the morning. Now look at me, Jim. Okay, I've got 24 virtual CPUs and 224 gigabytes of RAM to run this thing on, which is pretty amazing. And in order to submit this job, all you really need to do is right-click, submit job, and pick the context that you want to run, which is this VM that I already have set up over here. And you can have as many VMs in here. This is a special deep learning VM that we have set up in Azure for you. We also have data science VMs already set up. And I'm going to call this run number something random so that it looks nice. And then I'm going to import this, which is going to run this code on this remote machine. And if any of you have seen this before, this is going to run it 4 times. Because the more you run it, the smarter it gets. The more data you give it, the smarter it gets. OK, so I'm going to go ahead and hit submit. And it's going to load it up into this deep learning VM. So I'm going to go over here to jobs. Let me double click on that. And notice that it's running there, and there's another one running because a lot of us like to work collaboratively on this. Now, here is the cool thing that I want to show you, because one thing that I did not mention to you is that this thing also has 4 powerful GPUs, 4 Tesla K80s. And all of this training is happening on this deep learning VM, and you can see it running right there, right? And let me change the refresh rate to 30, from 30 to 5, so you can see this running. You can see that all of the GPUs are being used. You can see that this is going to run a lot faster than it did before, and it's going to enable you to run powerful AI or machine learning jobs to train the best models. To me, it's pretty impressive. I'm going to let it go for a little bit and go over here back to the job browser to show you some other cool stuff. Notice that you can see the standard error, the standard out, and the other thing which is even cooler is you can go to the working folder of where everything is running, and you can actually see the output of the runs that are happening as soon as it's done, of course. Right? And when it's done, you're going to see this thing called a model. Now, I want you to look at this, and we're going to leave this running for a little bit, and I want you to think about this, because one of the other powerful things that's really cool, and if you look just at the top where it says Azure Batch AI and this batch called HAL, you can also run this job, and elastically, the resources that you need will be called up, scaled out, and you can run this job using Azure Batch AI, which is pretty amazing. Imagine being able to run this on a deep learning VM with multiple GPUs, being able to run this on Azure Batch AI with a ton of other resources that are available for you. The other node that you see in there, which is really cool, is Azure Machine Learning. Now, here's the thing about building models. Notice that once the VMs are shut down or once the compute contexts are gone, you need to download that model and do something with it. But what if you want to collaborate with other people? What if you want to see how your models are improving over time across multiple runs? That's where Azure Machine Learning comes into play. With Azure Machine Learning Experimentation Service, you can run these models in the Azure Machine Learning context and see wonderful, beautiful dashboards that show you exactly how to run these things across runs, across with teammates as well. All right. So it looks like this is taking just a little bit longer. Let me go ahead and refresh here. OK. So as this is finishing up, again, pretty important. Remember, you can run these things locally like I did. You can run these things on a deep learning VM, or you can run this on a batch AI context, which I'm pretty excited about. OK. So I'm going to go ahead and go over here to this program and tell you a little bit. I'm going to set this as a startup project. And I'm going to tell you a little bit about another question that we have. Right? We know how to run these things. We know how to collaborate using Azure Machine Learning. But the question is, where do we put these things? Where do we put these models? So let's go ahead and switch over to the slides, because I think this graphic is probably one of the best ones that help me understand where I can put these models. Okay? So the first is, well, it depends. These models, if you think of them as a library or as an assembly or as a resource in your project, you either want to run them on the cloud because you might have a website. You might want to run them on premises because you might have some data, compliance issues that you need to work with. You can run these models locally on your own machines. Or finally, you can run them at the edge, remember, like we did on this device. One of the cool things that I'm proud to announce today is something called Azure IoT Edge. And Azure IoT Edge is a powerful way to take these models direct from Azure and push them down to the edge. And it's not just for machine learning. You can also do Azure Functions. You can also do Stream Analytics and a number of other things. It's like taking a bit of the cloud and putting it into your little machines. And that's a powerful tool that we are excited to announce today. All right. Let me go back here and make sure that the model is out there. Very good. Looks like it's there. If we can go back to the code. And I'm going to go ahead and download this and put it directly on my desktop. So I'm going to hit OK. I'm going to hit OK. I'm going to copy and replace it so you can see that it's the actual real thing that's out there. And to help keep me honest that it's really easy to use this in a C# application, I've invited my friend, Scott Hanselman, to help me out with this code. How you doing, Scott?
Good, good, good.
That's a long walk.
That is a long walk.
Fantastic. All right.
I have no idea what I'm doing.
All right, so let's start out, and let me show you. There is this digits program.
Okay.
So I'm going to make that a startup project.
All right.
Very good. And the first thing I'm going to say to you is I'm going to say, Scott, pretend that this model file that I just downloaded is like an assembly. What would you do?
I would add a reference to it, or if it's some kind of a resource, I would add it to my project.
Okay, so let's add it as a resource to the project. So right-click.
Add existing item.
Yeah,
you put it on the desktop.
Yeah. Dot
is
model.
that the one?
Yeah.
That's the. I'm going to make sure you're not cheating me. That's the one that you literally just made.
Yes, this is not cheating you.
All right.
I'm not wearing any sleeves.
You never know.
The
demos, it could all be lies, but I believe you.
Okay. So
then I would copy it over into my thing. So it's in the project now, and it's a resource that will be copied.
So now, usually when you have a resource, you need to load it up. Let's go to the digitrecognizer.cs.
All right.
And I want you to find the code. Maybe you can walk through it.
Okay, so making sure that things seem legit, you've got load model, and that could just be a function called do it for all I know. So I don't believe you. I'm going to just check.
Oh man, it's crazy. Okay.
Okay, so you load it into your function.load from the CNTK SDK, and then you squirrel it away into MNIST function. So it's sitting right there. That makes sense. Cool.
Okay, so fantastic. You notice that he said CNTK. There's also some NuGet packages that we installed in order for it to be able to reference the CNTK goodness.
Yep, makes sense. Cool.
There it is. Okay, so now that you have it, the assembly or resource loaded, what are the next couple of things that you need to worry about as a programmer?
Well, from a C# programmer's perspective, it's got methods, it's got things I want to call. So I'm going to go and I'm going to call the do it method or whatever the method is on the thing.
And so you need to know what you're going to pass in.
And so inputs and outputs.
So notice that we have a line 30 that's converting this picture, and it's literally just 2 for loops converting the picture into the 0 to 255 number that you said. But there's something interesting.
That's a good point here, because I think about things in terms of bitmap, system.drawing.bitmap, which is a Windows and .NET perspective on what an image looks like.
Correct.
But I know that in the machine learning world, you all think about things in terms of matrices and stuff.
Absolutely. And today, I am proud to also announce this new type that's going to go, and if you see the namespace, it should make you a little bit more comfortable, system.numerics.tensor of t. And this data type, tensor of t, is a very memory efficient way of passing data back and forth between .NET programs and things like CNTK. Because before, what you'd have to do is you'd have to load this thing up in .NET, you'd have to put it into this double array, and then you'd have to ship that double array, and then it would make another heap of memory, and then everything would be crazy. It's like too much stuff.
Right, so you're making a machine learning type like fundamentally part of .NET. So from a .NET perspective, I'm seeing system.numerics as opposed to Seth, who I've never heard of, .numerics.
We had to change it from
tensor.
that, actually, yes.
And it makes me feel more confident that I'm using something that is supported and get built into the system.
Fantastic. So we got the thing out. Now it's in a type that CNTK is going to understand. What do you do now?
Well, I'm going to do the conversion, right? So down here we go and we convert it, but then we call evaluate. We pass in that image data, that now converted image data, and we kind of load up our ins and our outs, and we say, do it, the evaluate. We pass in the input data map, the output data map, and then we tell it what device we're going to be doing that on, whether it's a GPU or a CPU or whatever.
Absolutely. Let's put a breakpoint. And also we unpack the data there at the bottom. Do you see that?
Yeah. So in this case here, you're taking the output data, which is a specific dictionary, and you're unpacking it and putting it into a list of digit results. And then you're being convenient and you're sorting it by confidence, putting the best results at the top.
It's like what we would do in .NET.
Yeah, well, it is .NET because that's what I know how to do.
Fantastic. So we set a breakpoint on line 97, and let's see with the model that we just built if you can actually fool it.
This is the one that you downloaded from Azure.
Yeah, we downloaded it. It's not like the fakeness. So it's going to load it up here. I'm going to take this pen here, And I'm going to let you, there you go. Just write it. Just,
Okay, what am I doing?
We're going to write a number, and
All right.
we're going to hit recognize. So any,
You don't show people your pin.
okay, yeah. No hands here. Okay.
All right.
Now let's hit recognize. And there's the breakpoint.
Okay, so we've got results here, and I can go and look at it down here in locals, and it's sorted by confidence. You have near absolute confidence that it is a 3.
Oh, hey, that's amazing. All right, let's try it. That's pretty cool, right?
All right, I like that.
Let's
But
try
I
another.
don't believe it.
Okay,
I don't
okay.
believe any of it.
Okay.
Can't trust you. I'm going to write a Portland 7.
Okay. Is that like a special Portland? That's a Portland 7 with
I just made that up.
Okay, all right, let's hit recognize.
I've just decided that that's a Portland 7.
All right.
Yeah, see, that worked as well.
That's pretty impressive, right? All right,
right.
now I'm going to ask you to try to write something that'll fool it.
Well, of course, I live in Portland, which is safely outside the Redmond reality distortion
course,
field,
of
so I'm going to
course.
draw a Redmond 4.
Okay, a Redmond 4. What does that looks like Klingon.
Yeah.
Okay. All right, let's see what the computer thinks.
Oh!
Oh, it did think it was a 4. I didn't think it was going to do it. Dang.
That's too smart.
Well, that ruined our script there, didn't it? So let's pretend this isn't scripted and it made a bad mistake. So,
no, I mean, apparently it's learned.
Yeah. So the cool thing is, like, when it makes mistakes,
This was when Skynet happened at this moment.
it was right here.
So I'll just remember that.
Sorry, the robots
This
are
is
taking
when the
over.
machines learn too
We're
much.
friends. But here's the thing. When it makes mistakes, you've all seen this in applications, that it says, how did I do? And you say good or bad.
Yep.
Or, for example, if it got the number wrong, you say, no, this is actually a 7.
You upvote it, you downvote it, you teach it so that it might learn better.
And in this particular application, we're not doing that, but imagine an application that will save this data, and then you can run on those deep learning VMs or Batch AI or Azure Machine Learning, rerun the model every Saturday because computers don't mind working on the weekend.
I've heard that.
Yeah, it's pretty cool. Okay, so this is a kind of a cool program. Let's stop this. And we've made another program that's a little bit more aspirational. I'm going to have you go to the next instance of Visual Studio here.
All right.
This is called the Picture Style Transfer, and I want you to scroll down over here on the Solution Explorer. Notice that in this one, we're loading up multiple models that are doing different things. And the idea is, what we did is we loaded up some really artsy pictures, and what we've done is we built models that take other pictures and convert them into the artsy picture.
So in the style of.
In the style of. So let's run it.
Okay.
Let's run it. And let's take some pictures here because that's what everyone
This is
wants
going
to
to put these artists out of business, hopefully not.
Yeah, well, not hopefully. And again, maybe we should sell stills of these after the show. If anyone wants to buy stills of these.
All right.
All right, so what we're going to do is notice that it's already picked a selected style. So we're going to get in front of the camera and we're going to try to take a picture. That's beautiful.
There's wrinkles there that are not in the other
No,
picture.
those are really there in real life. Just FYI. All right, let's go down and do mosaic.
Okay.
And let's take that picture of that. Like these, we could probably sell these prints.
That works.
Yeah, I mean, it's beautiful,
It's
right?
nice.
All right, so what did you think? Was it as hard as you thought it might be?
No, because I'm actually going to be adding this to my resume as AI ML expert.
Engineer.
I'm taking full credit for this entire demo and for all of the power of Azure.
Fantastic. Thanks so much,
Thank you,
Scott.
sir.
That was awesome. All right, so I actually went through the entire machine learning process. Obviously, it was abridged. Obviously, there's going to be a lot of trial and error when you do this, but we have the particular tooling to help you do that with Visual Studio Tools for AI. So, to recap, we were talking about building applications of the future. There were 3 core concepts that we wanted in order to do that. The first was we want to infuse it with AI. We can do that easily, quickly, using cognitive services. We talked about new app experiences, and we gave you an example of that with bots. And we talked about how data is very important when it comes to these new applications of the future. And we showed you how to take data, create models inside of Visual Studio and on the cloud, and collaborate using Azure Machine Learning. We showed you how to do that on top of a ton of data. So many of you are wondering, well, what can I do to move forward? We are, again, today announcing aischool.microsoft.com, so you can become more familiar with these things. Notice that what I told you conceptually is not hard. Just like any other programming thing that outputs artifacts that then we import and we use as an abstraction, you can do the same thing with AI. I hope you were sufficiently educated about this stuff because I'm still learning about it. I hope you will too. Thank you so much for your